Here we are in lesson 8C, which is about special right triangles. We're going to talk about two types of special right triangles. The first one is a right triangle, so it's 90 degrees in the corner, but the other two angles are 45 and 45. And then later we're going to talk about another right triangle, 90 degrees in the corner, but its other two angles are 30 degrees and 60 degrees. So those are the two types of special right triangles we will get to today. Before we do, here's a warm-up for you. You can pause the video for just a second and see if you can figure this out. This is a review of some of the stuff that we talked about back in Unit 6 or 7. The side length that couldn't be the length of this side of a right triangle would end up being 4, 6, and 8. Okay? The reason is because 4 squared plus 6 squared does not equal 8 squared. Okay? And therefore it couldn't form a right triangle. Here's one more warm-up for you. What's the length of that missing side, the hypotenuse of that right triangle? Again, pause the video for just a second, see if you can figure it out, and then come back. In this case, we would need 3 squared plus 6 squared equals c squared, and after we work through the algebra on that, we would end up getting 3 times the square root of 5. That's the side length of hypotenuse. Alright, so let's dive into our special right triangles, and in this video we're going to talk specifically about that 45, 45, 90 degree triangle. Down at the bottom of your page of notes, you see something like this. So the big thing to remember is what I've got listed there. In a 45, 45, 90 degree triangle, the hypotenuse has to be square root of 2 times as long as each leg. If we were going to put that in more of a mathematical format, it would look like this as an equation. Hypotenuse equals the leg times the square root of 2. Okay, if you want, you can go back to page 463 in your textbook to see the proof, but I'll show you something real similar to it down at the bottom of the page. The reason this equation always works, and again, we can only use this equation in a 45, 45, 90 degree triangle. The reason it works is because if I look at how that is set up, I could use the Pythagorean theorem, right? I know if it's a 45, 45 degree triangle, that those two angles are the same, which means it's an isosceles triangle and those sides are the same. So I'm going to have x and x, whatever that value is. If I call the third side my hypotenuse, which it has to be, it's across from the right triangle, it would be c. So let's put that into an algebraic equation. I'll bring that in from the side here. It looks like this. I've got my side lengths, my legs, x squared and x squared. That would typically be your a squared and your b squared, and you would set those equal to the hypotenuse, which is c squared. Okay, in this case, that's my first leg and my second leg. I don't know what they are, but I do know they're going to be the same, so I can call them x, and now x squared and x squared. Okay, when I start simplifying that, these two combined form 2x squared, and I set that equal to c squared. Okay, now I want to take the square root of both sides, so I get c squared by itself. When I do that, the square root of c squared becomes c. The square root of all of this, I can pull an x out on the outside, is x times the square root of 2. So it did not matter what x actually was. I know x times the square root of 2 is going to be equal to c, my hypotenuse. Hypotenuse is equal to x, the leg, times the square root of 2. Okay, so this is just proof that the hypotenuse equals the leg times the square root of 2 is always going to work in a 45, 45, 90 degree right triangle. So let's look at some practice on the next side of your notes. Okay, we've got these two different problems right here. And the first thing I would really suggest that you do is take the extra 3 seconds to just write down this equation. Maybe shorten up hypotenuse. I like to just say HYP equals the leg times the square root of 2. Okay, it doesn't take long to write that down, but now it's just substitution. Do you know what the hypotenuse is? No. So just continue to call it hypotenuse. Do you know what the leg is? Yes, you do. It's 8 times the square root of 2. Can I go any further? Nope, that's it. I've just solved for the hypotenuse. It is 8 times the square root of 2. If you want a more a rounded answer that may be a little bit more clear, you can plug 8 times the square root of 2 into your calculator and see what that is, but this is the most specific value. Now let's take a look at the one on the right hand side. Again, I'm going to take just a little bit of time to write down hypotenuse equals leg times the square root of 2. Do I know what my hypotenuse is? Nope. So I just rewrite it. Do I know what the leg is? Yes, I do. Doesn't matter which one, they're going to be the same. The leg is 3 times the square root of 2, and I'm going to multiply that by the square root of 2. Okay, so my next step, I've got to go a little bit further algebraically in this one. Square root of 2 times the square root of 2 is 2. Okay, so altogether that's 2. Bring your 3 down. The hypotenuse must be a total distance of 6. Okay, let's go through 2 more. If you want to pause the video before we go through these and see if you can get these on your own, that would be fine. I'm going to work through them as well. So again, hypotenuse equals the leg times the square root of 2. That's an equal sign. This time we do know the hypotenuse. We don't know the leg. So we're trying to find the leg in this case. Fill in what you know for the hypotenuse. In this case, it's 5 times the square root of 2. Equals x times the square root of 2. The leg is x. If I want to get x by itself, I'm going to divide both sides by the square root of 2. When I do that, those cancel here. I'm left with x. And when I do that here, those cancel. I'm left with 5. So the length of each side here, the length of x, must be 5. And then one more on the right hand side. Hypotenuse equals the leg times the square root of 2. I know the hypotenuse, it's 8. I don't know the leg, so I'll call it x. It's written as x as well. And we're going to multiply that by the square root of 2. Again, I want to get x by itself, so divide both sides by the square root of 2. Over here, those are going to cancel. You're going to be left with x. On this side, we're going to do a little bit of work with this, and that's just because we don't like seeing a radical in the denominator. So in order to do that, you might remember, bad parentheses, but we're going to multiply by square root of 2 over the square root of 2. That's the same as multiplying by 1. But what it allows us to do is to have these multiply, I shouldn't cross them out, but they're being multiplied across the bottom. Square root of 2 times the square root of 2 is 2. And on the top, we've got 8 times the square root of 2 equals x. Okay, so we're almost done. You can also simplify because now on the outside I've got 8 over 2, which is the same as 4. So 4 times the square root of 2 equals x. And that's how you make use of this hypotenuse equals leg times the square root of 2 equation. And again, you can only do this if you know you've got triangles that are 90, 45, 45. What I really need to see and double check is that I know I'm dealing with an isosceles right triangle. In these cases, because I saw that the sides were the same, I know that the angles must be 45 degrees. Same thing over here. These sides were the same, so I knew for sure I was dealing with a 45, 45, 90 triangle, and then I could set these up the way that I did. One more thing in your notes. This is a challenge for you. If you think you've got this equation down, you're able to work with it. I would like you to try this challenge problem. If you want to stop the video now, you can. Essentially what we're trying to do here is try to find this length. In order to find that length, we're going to need to find this length first, which would tell us the same length here, and so on. So you're kind of working your way from outside in so that you can find x. Pause that video now and give it a shot. And the answer to this problem ends up being 10 times the square root of 2 for that value of x on the inside.